Hello and welcome to my YouTube channel. Today I'll be talking about Kirchhoff's voltage law. Kirchhoff's voltage law states that the algebraic sum of voltages in a circuit is zero. So if, for example, we have this circuit diagram here, if we do the algebraic sum of the voltages in this circuit, then the answer should be zero. Now, what do you mean by algebraic sum? Algebraic sum is a way of indicating the difference between the voltage source and the voltages across the resistors, right? So when it comes to the resistors, we tend to indicate polarities on the resistors. And the polarities are just the plus and minus you can see here. And then this positive and minus can be indicated based on the direction of the current that is passing through the resistor. So you can see here I have I, which is the current is passing through this resistor. So the first terminal where the current enters the resistor is positive. When the current leaves, it's negative. The same thing here, the current enters here, the first terminal is positive. When it leaves, it's negative. Right. So we have indicated now the polarities. The next step is now to do the algebraic sum. Algebraic sum here, we are going to consider minus to positive as rise and then plus to negative as drop, right? So, in doing the algebraic sum, we can go clockwise, right, or anti-clockwise, right? So here, when it comes to this circuit, for clockwise direction, we have minus to plus, so that's right. And then here we have plus to minus, that's voltage drop. And the voltage there is V1. Here too, we have plus minus is drop. So the voltage there is V2. So we have Vs minus V1 equals what? 0. Now we can do the same thing, right? Anti-clockwise. We can perform anti-clockwise direction. So we have here minus Vs. So here we are moving anti-clockwise. So we have plus minus will drop. And then here we now have minus to plus being right, and then here minus plus. So we have Vs minus Vs plus V1 plus V2 equals to 0. And both of these will give you the same answer. So we have Vs equals to V1 plus V2. You simplify it because we know V1 will be equals what? I1, I here times I1. And then V2 is I times what? I2. Now that we know how to use Kirchhoff's voltage law, let's try and use it on this example. Now, the same thing here. Here I've already indicated the current, and then not only the current, but also the polarities as well. And you can see here the current direction is moving up, so we have plus minus. This current is moving down, plus minus. So moving down as well, plus minus. And then when it comes to I3, you can see it's also moving down. So we have plus minus on the resistor R4. Now we can go ahead and then apply Kirchhoff's voltage law to this closed circuit. And then you can see here we can move clockwise direction. We have the minus to plus, which is what? Rise. And then here we have drop. So we have minus V1. And then here plus to minus is drop. So we have minus V2. And then here we have minus to plus to minus, which is drop. So we have minus V3, which is equal to 0. Now you can pause this video and then try and then apply Kirchhoff's voltage law to this second closed circuit and see what you are going to get. So if you do it very well, you realize that here, again, we can start from any voltage. So if you start from V2, minus to plus is rise. So here, plus to minus, that will be drop. So we have what? V2 minus V4. And then here, minus to plus is rise, which is also plus V3. So you take the minus V4, you take it cos A equals sin becomes positive. So you have V2 plus V3 equals to V4. So this is how you apply Kirchhoff's voltage law. And I'm going to be doing another video on Kirchhoff's current law. So make sure you subscribe to this channel and then share the link so that other students can benefit from this. See you in the next video. Bye-bye.